Waves move through substances carrying energy from one place to another, and once they've gone, it's as if they were never there. A wave is an oscillation or a vibration that transfers energy without transferring any matter, by making the particles of the substance that it is traveling through oscillate. Waves can be either transverse or longitudinal. These words sound complicated, but they describe something simple: the direction of the wave oscillations. Waves transfer energy in the same direction that they travel. Transverse waves oscillate at right angles to the direction that they travel in. In transverse waves, the oscillations are perpendicular at 90 degrees to the direction of energy transfer of the wave. Examples of transverse waves include light and all other electromagnetic waves, ripples on water and waves on string or springs when they're wiggled up and down. Longitudinal waves have oscillations along the same line as they travel. They have areas of compression in which the particles are bunched together, and areas of rarefaction in which the particles are spread out. In longitudinal waves, the oscillations are parallel to the direction of energy transfer of the wave. Examples of longitudinal waves include sound waves and a spring when you push the end. All waves transfer energy in the direction in which they are traveling, but they don't transfer matter. When waves travel through a medium, such as air or water, the particles of the medium oscillate and transfer energy between each other, but overall the particles stay in the same place. Only energy is transferred. You need to be able to describe some observations that provide evidence for this idea. Ripples on a water surface cause floating objects like twigs or birds to just bob up and down. This is evidence that the wave travels, but not the water. If you strum a guitar string and create sound waves, the sound waves don't carry the air away from the guitar to create a vacuum completely. You need to know that waves may be either transverse or longitudinal. You need to know on a longitudinal wave the difference between a compression and a rarefaction, and you need to describe the differences between the two types of waves. You should also be able to tell me some evidence that shows for both ripples on a water and sound waves in air that it's the wave and not the water or air that travels. In class, we're going to complete a compare task like this, so you will have a summary that's easy for you to revise from. Make sure that you do not lose this.